Hello, algebra students. We are going to look at two inequalities that a student in our Facebook group tried to solve and got stuck on. And we're going to ask ourselves what went wrong. Taking a look at your work, going back, looking at your habits and the mistakes you tend to make. So valuable for learning. And by the way, if you're not in our Facebook group, you should join it because you get so much help there. So let's take a look at this first example. Now, both the examples we're going to look at are from Algebra Essentials, Lesson 12, the Did You Get It quiz, which is only available if you join the adventure. So you can do that by getting the online course or getting the workbook. So let's take a look. Number 5 says 3x plus 5x is less than 48. And the first thing I notice is that this student did not do the same thing on both sides. I imagine that she thinks she did. However, take a look on the left-hand side of this inequality. The student decided to subtract 3x, which I guess you could do. It's not going to be my first step when I go to do it, but take a look at the right-hand side. Even if you chose to subtract 3x from one side, you didn't subtract 3x from the other side. You simply subtracted 3. And so right away, you changed the relationship between these sides. Let me change colors. That's a little hard to read. You changed the relationship between the two sides, and so you basically broke algebra. So first step, remember, whatever change you're making, it has to be exactly the same on both sides, not kind of the same. That being said, though, that's not where I would have started. So I'm going to have you remember your wisdom principles that I taught you guys for solving multi-step equations and inequalities, same thing. Now, these are all linear equations and inequalities. You're going to need more than this for quadratics, but most of the ones we have on the GED are of this style. So your very first step that I asked you to do was, if possible, simplify the expression on the left-hand side and or the right-hand side. Now you might say, Kate, why are you talking about simplifying expressions? That was like so many lessons ago. Now we're supposed to be solving inequalities. Yes, but remember what an inequality is. It's just an expression related to another expression, something on the right, something on the left, by some type of an inequality symbol, in this case, a less than symbol. And so, yes, this is an inequality, but it's composed of two separate expressions, an expression on the left, an expression on the right. So if either one of those will simplify, do it. And a really great rule of thumb if you're getting lost in symbols, and it looks like from all the work I've seen from the student, they do get very lost in symbols, is to only look at one side at a time when you're looking at these multi-step equations. So you can even block it off with a piece of paper, but sometimes I'll have people just completely block the right-hand side and look individually at the left-hand side. And you can see that on that left-hand side, 3x plus 5x, that is an expression we can simplify. Those are like terms. I have some number of x's plus some other number of x's. If you can simplify that expression, do it. So that left-hand side would be more simply called 8x. Now, that being said, we know that this wasn't just a single expression. This was two expressions. So I'm going to go ahead now and look at the other side. Of course, the less than is not going to change. That's what it already was. Now, the right-hand side, though, was 48. Can I make 48 any simpler than it already is? No, it's just a single number. And so there it is still as 48. And this just got way simpler because now it's just a one-step inequality now that I simplified. So we can see I don't even need wisdom principle 2, which is bring the variable terms to the same side, because the x is only on one side. It's only on the left-hand side. And so that's not even an issue. So now we can go to the third step of the wisdom principle, which is isolating the variable, working to get the letter alone. And so I have an 8 and an x shoved together. They're multiplying. I will do the opposite. I will divide away that 8. I can do whatever I want, again, as long as I keep those two sides equal. So I'm going to do the exact same thing on the other side. Exact same operation, exact same number. And then let's see what happens. Multiplying by 8 and dividing by 8 cancel. I'm left with just x. Wow, guys. And I've done nothing that's going to flip the inequality sign. I didn't multiply or divide by a negative. And 48 divided by 8 is 6. And so I get this final answer that x is less than 6. Now, if you're one of those students who really struggles to see the left-hand side from the right-hand side, super common issue, especially with students with certain learning disabilities like dyscalculia, but certainly not only that. Really good rule of thumb that I taught you in the math abilities, and be doing those math abilities there for you, was to draw that line through that inequality symbol or equal sign that allows you to not only look at it all together as an inequality, but to look at it as two distinct expressions. Awesome. All right, now let's look at the next one. The next one was a little different for a whole nother reason. All right, next example was 6, and I can see the very same error happening right away. On one side, the student chose to add 7y. On the other side, they chose to add only 7. Those two things are not equal. They're not the same. And so right away, we are doing something that would break math. And so none of the rest that follows is legitimate because I have not done the same thing on both sides of this inequality. That being said, though, even if I did choose to do that, the answer that you got underneath was not the same, because think about was not legit, I should say. Because think about what 7y plus 7y would be. It would be 14y. And you haven't even done what you wanted to do by making this thing any simpler. And if I did add 7y on the other side, 5y plus 7y is 12y. I can only add y's with y's, minus 30. And it's a legitimate thing. I guess I could add 7y to both sides if I wanted to, but it's not helping me any. It's just making this thing ugly and more complicated. So then what should I do first? Let's take a look. So I think I'll rewrite this out. 7y is greater than 5y minus 30. And I'm going to encourage the student, whoever they are, to really go back and do the math ability videos, because this is when I teach you all these tricks. Okay, so I'm going to put that line through that greater than sign so we can see the left-hand side from the right-hand side. And I'm going to walk through those wisdom principles again. So wisdom principle number 1 was simplify if possible. Can I do any work on the left or right-hand side? Again, when I'm simplifying, I'm only looking at one expression at a time. So let me ignore the right-hand side and look at the left-hand side. Can I make 7y any simpler? No, I sure can't. Again, now I'm going to look at the right-hand side. Ignoring the left-hand side, I look at the right-hand side, 5y minus 30. Can I do that subtraction? No, I sure can't. They're not like terms. And so cool. I don't have to simplify the left-hand side and the right-hand side. What I do need to do, though, and this is what this student did see, they saw that I needed to do this, was I needed to get the variable terms to the same side. Why do I say that? I say that because I have a y on the left-hand side of the inequality and a y on the right-hand side. Really good wisdom principle is to get those together before you start trying to move the numbers away. Now, I absolutely love that the student used addition or subtraction in order to move the variable terms, so they knew that we had to do that. But the problem, though, was if they really wanted to take away 7y, they should have subtracted 7y. But I'm going to tell you, I don't want to take away the 7y. Here's why. If I took away the 7y and 7y minus 7y, I'd have 0. I'd have nothing over there. And indeed, that was my biggest issue with the work over here. Your entire left-hand side disappeared. Your inequality symbol disappeared. Left-hand side inequality symbol gone. That is a huge red flag that you need to go back up to where you came from. if you ever drop an expression, whether you're solving equations or inequalities, all of a sudden you don't have a left-hand side or you don't have a right-hand side. Your equal dropped out. Your inequality dropped out. You've gone totally astray, because every single line that follows should be a new inequality, a new inequality. All right. So what am I going to do instead? I'm going to bring the 5y over to the 7y. And then I won't have this weird 0. I think I like that better. Not that it would be wrong if you took away the 7y. It's just going to get more confusing by adding that 0. So let's actually move the 5y. Now, again, if I want to take that entire 5y away, though, don't add 5y. That would give me 10. I want to subtract it away so it zeroes out. And now, of course, I can do the same thing on the other side. Notice that on both sides, I have a minus, I have a 5, and I have a y. Identical, identical. Be able to see that balance change. And we've talked about this before, but I really need you to be really clean with your balance change versus your new inequality or equation if I was solving equations. And you can see, and I do this in the Mathability videos, you can see that I'm using a different color for balance change than I am for my new equation or inequality. So I can help myself visually see the difference. All right, so let's see what my new inequality will be. 7y minus 5y gives me 2y. Now, I haven't done anything that would change the inequality symbol. Some students say, Kate, but there's a negative there. It's only when you multiply or divide by a negative that we see that inequality symbol flip. So it's going to remain nice and steady. And then, yes, if I have 5y and I take those 5y away, I subtract them away, I'll have nothing there. I'll have 0. And of course, if I had 0 minus 30, it just ends up being negative 30. So drop that minus sign with the 30. I'm subtracting 30 from nothing now. And so I'm just negative 30. All right. And now we can see, now that we got those variable terms together, now it's going to be really easy to isolate the variable. Get the letter alone by using those inverses, those opposites on both sides. So since that's 2y, the 2 and the y are multiplying. So I'm going to make a change. I'm going to divide by 2. And of course, my change is always balanced. If it's written in orange, if it's written in my other color, if it's a change I'm making, I do it on both sides. See why I like to flip colors? And we can see it's identical. Same operation, same number. And now it's time to write what my new equivalent inequality will be. Multiplying by 2 and dividing by 2 really are opposites. And so they cancel. Y is alone, just like I wanted. I've done nothing to affect the inequality symbol. I didn't multiply or divide by negative. And negative 30 divided by 2 is negative 15. Okay, so the advice I'd have for this student is you definitely have a symbolic processing issue. And I know you. I have seen you working so hard for so long, and I know you're frustrated. And really, it's the symbols are dancing on you. You're trying to memorize steps, and you're working really hard. I want you to be successful. So please go through that algebra unit and do those Mathability lessons for me. I'm not trying to slow you down. I'm trying to make it so that your study work really is productive for you. And to everybody out there who the symbols dance, they drop, negatives fall out of your problems, equal signs disappear, your lines are disjointed, you get lost in the symbols. You are who I made Mathability for. Whether you have a diagnosis or you don't have a diagnosis, those symbols are, you're struggling to unlock meaning from them. And that's what we do in Mathability. We spend all this time meaning to symbols, so you can learn the language of algebra, so can it stop being so dang confusing. All right, lecture from Mama Kate over. I love you guys. I want you to pass your tests already. That's why I'm here. All right, happy learning.